Hello everyone. Today we'll be building a zombie escape game using an Arduino. We'll start by building the circuit with an LCD display, a joystick, and a buzzer. Then we'll code the complete game. We'll be creating a start screen with a difficulty selection, as well as building an engine to generate the maps and update the screen. We'll also need to build the AI to automate the zombies' movements, as well as collision detection. In addition, we'll be creating special characters for the LCD display for the sprite animations. For this project, we'll need the following components: an Arduino Uno R3, a 220 ohm resistor, a 100 ohm resistor, a 5 kilo ohm resistor, a buzzer, and a 16 by 2 liquid crystal display. In addition, we'll need a breadboard and some jumper wires. All of these components are in the Arduino starter kit. Source files, schematics can be found in the description below. If you find value in these videos, please make sure to like and subscribe. Let's start by taking a look at the gameplay. All right, let's go ahead and start the coding portion of this project. Let's go ahead and open up the Arduino IDE. And on the left side, let's go ahead and click on the library icon. First, we want to start by making sure that we have the liquid crystal library. Go ahead and just type in liquid crystal and make sure that that's installed before we begin. All right, let's go ahead and include that header file for the Liquid Crystal library. And then we're going to go ahead and we're going to set the pins for the LCD display next. All right, then we'll go ahead and call that library and assign those pins. Let's go ahead and set the pins for the buzzer and the joystick start button. And then let's go ahead and define the pins as well for the x-axis and y-axis. We're going to go ahead and define a bunch of just default variables for the program. The player's position, which row they're on, which sprite we want to use, the zombie's position, which row he is on, as well as the default score and lives. We go ahead and declare variables for the key location and the door location. And beat, we'll use that later on to play a little song. We're going to go ahead and set some Boolean values for if the player has the key and if the game is started or not. Then we're going to go ahead and set some variables just for the joystick pins. This is just reading that x value and y value from the variables we just set. What we're going to do here is this function is going to respond back with the position if we're left, right, or if we're pointing up or down on the joystick. We'll go ahead and use 600 and 400. The joystick will have a range from 0 to 1000. The default is kind of 500 as a neutral position. So we'll just set 100 pixel each way, kind of dead zone. That'll kind of help the joystick from being overactive. So we'll have 4 different outputs, 1, 2, 3, and 4. Next, we're going to go ahead and we're going to build out a function for inputting a sound. We're going to take in the frequency and the duration that we want to play the sound. We'll go ahead and make a tone for that frequency, call the buzzer, and then here's the duration. We'll go ahead and put a delay for that duration and then turn the tone off after that duration has passed. Next, we're going to build out the function to actually move the player. This is where a lot of the logic for the player moving is going to take place. Go ahead and just declare some default variables there. We're going to go ahead and copy the current position and make variables for the old position. That way we can reference back to the previous position. We're going to go ahead and get the input from the joystick. We're going to set that as a direction variable. And this is just going to kind of be for the default position. If there's no position set, we'll go ahead and set the user to the default position. Next, we're going to go ahead and get the response from the direction. This is where we're going to set the logic to what we do with the direction. The player is moving to the left, or if the player is trying to move to the right. We're just going to add one to the position or take one from the position. We're going to also check to see if the player is trying to go up or down. We will go ahead and move them to the proper row. If they're on the first row, then we can move them to the second row. If they're trying to go up, if they're trying to go down, then we can do the inverse. Next, we want to kind of convert the actual position to the comparative, do a comparative statement that's make it into a single integer instead of the column and the row. And we'll write the function for this down below. But we'll just go ahead and write the code for it right now. Okay, so now what we want to do is we want to see if the new position is within the bounds of the map. We also want to check to see if there is anything blocking. If there's a wall blocking them, then we will prevent them from making that move. And basically we want to check here to see the character that needs to be replaced. If the if the player's going to move, then we need to write the character that should be in their current position back to the screen. Basically redraw the character for the position that they're currently at. Next, we want to check to see if the player is standing at a position where the key is. If they are, then we want to go ahead and give them the key. And then we want to remove the key from the map. Next, we're going to want to see if the player is standing at the location of the door. And if they are, we want to check to see if they have the key. If they do have the key, then we want to go ahead and just increment the score. And then we want to end this round, in this level, and then we will start a new level. We'll play a little sound there, increment the score, start the new level. Go ahead and add a little delay down here. All right, and if the player tries to move to a position that's out of bounds, we're going to go ahead and keep them in the same position by just taking our original, our old player row, and then just going to reassign those to the player row. Then we'll go ahead and write that to the screen, and then return. Next, we're going to go ahead and build out the functions for the zombies movements. These will be very similar. A lot of this we could probably cut and paste. But we'll go ahead and just build it out anyway. And just once again, declaring some variables, copying the original position to a new position in case we need to move them back, in case it's an invalid move. Now we want to kind of just build out the logic for following. This is going to be his AI. This is basically going to say if he's the zombie is above the player's position, he's going to try to move left back towards the player. If it's the inverse, then he will move to the right. Next, this statement is going to say, if the zombie and the player are at the same position, but on different rows, the zombie is going to move to the row where the player is. Next, we are going to call that convert position function again, and we're just going to basically say that to convert the two integers, the column and the row, into one single number that we can then do some comparative operations on. We're then going to see if the zombie is within the bounds of the map, if the new move is a valid move. Then here we're going to move the zombie to the other row if he's at a wall. If he's at a position where there's something blocking him. And now we're going to look up the current position on the map, see what element needs to be placed in the place where the zombie is currently standing. And if there is no character, we'll go ahead and just put a blank character there. Then we'll go ahead and write the new position to the screen, the new zombie's position. Then we'll go ahead and do our else statement. If the zombie has not made a valid move, then we're just going to go ahead and write him back to his current position. Next, we're going to build out the function to actually convert the positions from that column and row into a single number. And we'll do this by taking, basically we have 26 characters. So we can basically divide that in half and then get, if they're above 13, then we know that they're on the second row. And then just return that single integer. All right, next, before we continue, let's go ahead and put in our maps here. And these are going to be just arrays of 26 characters. I'm just going to go ahead and paste them in, and then we can take a look at them. So this is the 5 different maps. So it's 5 different arrays of 26 characters. And if we look, we can see where the zeros, where blank spaces are. I'm going to go ahead and see 7, which is going to be the element of the door. 8 is going to be the key. And then 219, those are going to be the elements for our walls. Next, we're going to go ahead and paste in our actual characters for the screen. And we'll have 8 different characters, which are the max, so we cannot put any more than that using this type of display. These are the sprites for the zombie looking left and the zombie right. And then we'll go ahead and paste the players looking left and looking right. And then we'll go ahead and add in the remaining characters, which is going to be a heart, like a trophy, the door, and the key. You may be wondering how we generate these characters. To do so, there are some tools online that will help us do so. If you want to open your web browser and navigate to omeek.github.io/lcdchargen, and this user has created a little special tool that allows us to generate our characters. We can go ahead and just fill in the bubbles with the character that we would like to generate, and on the right side here it will actually generate the output for us. We can simply cut and paste that back into our program. The only thing that we'll need to do is just change the name of that variable. And then we'll reference that later on. All right, so now we can go ahead and build our code to actually generate the maps. All right, first thing we're going to do is we're going to iterate over each item in the map array. Iterate over all 26 characters of the map. Next, we're going to, if the item is not blank, then we'll go ahead and proceed. If not, we'll skip over it. Next, we're going to see if it goes on the first row, then we're going to go ahead and write it to the screen. Then we'll go ahead and see if this location has a key, then we're going to go ahead and set the key location variable. That way we can reference that back. Then we're going to go ahead and do the same thing for the door. We'll go ahead and see if we're at the location of a door, then we set the door location variable. Then we're going to write the function as if the item is on the second row. Now we just go ahead and cut and paste this code right down here for the key location and the door location, and that'll be fine. Maybe some way to optimize that, I'm sure. Next, we're going to go ahead and write the function to update the lives. This is just going to update the lives displayed on the screen. Then we'll go ahead and pretty much write the same function, but to update the score. Really probably could be written into one function, really. All right, now we'll go ahead and build out the actual function to start the game. This will actually start each level. We'll call this every time we start a new level or we're restarting a level. First, we want to check to see if all the levels have been completed in one. Then we're going to go ahead and end the game and display the winning message and play the song. We're just going to check to see the size of the maps array. And if the size of the maps array is the same as the score, then we'll go ahead and stop the game, clear the screen, display the ending game message. Next, we'll go ahead, we'll just paste in a song here. I'm not going to go through the code of this. Go ahead and clear the screen. We'll reset the score and the lives, and then we'll go ahead and return. All right, next we want to go ahead and finish this function by just declaring the variables to reset the game state back to a default. Go ahead and set the player and the zombie's position back to where they start at. If the user had the key and they lost, then we'll go ahead and take that key from them. Go ahead and clear the screen. And then we'll update the score and the lives, and then we'll regenerate the map, or generate the map if it's the first time it's loaded. Okay, now we're ready to actually start building the code for the game. Now that we've built all the functionality, we just got to put it all together now. We'll go ahead and just start by setting the pin modes for the start button and for the buzzer. Then we'll initiate the screen. After this, we're going to go ahead and we're going to define those special characters that we created into actual numbers to where we can identify them as integers. So we're now giving them using the same name as the array that we've called up higher with all those cryptic special characters that we generated. Now for the door and the key. And now if we notice, we have 1 through 8, and we have all these variable names that now match the name of the array of the characters that we defined up top. All right, now we can go ahead and build out our loop. We just want to go ahead and start by calling the actual pin to read the joystick, basically polling the joystick to see what the position is before we start the loop. We basically want to declare two if statements here, if the game is started and if the game is not started. Let's go ahead and code out the game not started. So essentially this is going to be our start screen. Basically what we're presented with when the game first loads. And then we're going to play a little theme song down here. And we'll just go ahead and paste that in there. That's one song. It also creates a dancing character as well. Now we're going to go ahead and we're going to check to see if the start button is pressed. If the start button is pressed, we'll go ahead and start the game. We'll go ahead and change that game started variable to true. And we'll just call the start game function, and that'll pick it up from there. We'll just need to return. Now we can go ahead and check the joystick position to go ahead and see if the user is trying to request a different difficulty level. We'll first go ahead and see if the selection is set, change it to easy if the joystick is being moved down. And our zombie speed is actually backwards. 2 is going to be our slow, and then 1 is going to be fast. And all we're really doing to change the game modes is changing that zombie speed. So we'll just go ahead and cut and paste that, change it to hard, change the selection to 4, which is the joystick going up. And then we're going to go ahead and just copy that again. This is just our default condition. If a user hasn't selected up or down, it just kind of sets it to easy to begin with. And then we can set it after that. Okay, so now we're going to go ahead and if the game has been started, then we're going to go ahead and proceed with the gameplay. First, we're going to go ahead and check to see if the zombie's position has been updated. So we'll just go ahead and use that zombie speed variable. We'll just go ahead and make sure that that's set. We're very easily going to call that move zombie function. We're going to send it our current position, and it's going to return back the new position. Next, we're going to basically write the same piece of code, but instead of calling the zombie function, move zombie, we're going to call move player. We're going to give it our current position. It's going to respond back with our new position. Next, we're going to check to see if the player is standing at the same position as the zombie. If it is, we're going to go ahead and remove one of the player's lives, and then we will go ahead and just update the scoreboard on the screen. Then we need to make sure that we put the key back on the map because we took it off. If we already had the key, then we've taken that out. So we'll just go ahead and put that back. Now, the next thing we're going to do is if the player has no lives left, we're just going to go ahead and in the game. We'll go ahead and print the game over message. And then we'll play a little jingle. We're going to reset the score on the lives, and then we'll return. Then basically, if we do have lives left, then we'll go ahead and just restart the level or proceed to the next level. All right, and all right, let's go ahead and compile and see what we have here. Oh, looks like we have a few bugs. Oh, okay. Okay, yeah, it looks like the define does not need semicolons. Go ahead and remove those out. Oh, looks like start game should have been, it's actually a function that we want to call, not a variable we want to set. And yeah, convert position and not converted position. Cool. All right, let's go ahead and proceed. Let's go ahead and get this circuit put together. We'll start by laying out our breadboard and our Arduino. Next, we'll go ahead and just connect 5 volts to the positive side of the bus on the breadboard. Then negative to ground. I went ahead and attached this ribbon cable to the joystick for simplicity. Go ahead and just mount that about right there. And then what I'm going to do is go ahead and use these 2 thumbtacks to hold it down. That seems to work pretty good. Next, let's wire power and ground from the joystick to the bus bar on the breadboard. Positive going to 5 volts and negative going to ground. Next, we'll connect the switch wire to D9 on the Arduino. Okay, so now we're going to hook up the X and Y axis from the joystick controller to the analog inputs on the Arduino. We're going to hook A0 to X and then A1 to Y. Next, let's go ahead and wire up our buzzer. We're going to take a 100 ohm resistor to ground to the negative side of the buzzer. Then we'll take positive side of the buzzer to D8. Let's go ahead and wire up our LCD display. Let's go ahead and just stick that down in the breadboard as such. Then we're going to wire VSS to ground. Next, we'll wire VDD to 5 volts. Next, let's hook up V0 to 5 volts using a 5 kilo ohm resistor. You could also use a potentiometer if you'd like. Now for RS, which is going to go to pin D2. RW will connect to ground. Next, the enable pin will hook to pin D3. Now for the data bus. There's 4 data bus wires, D4, 5, 6, and 7. We'll go ahead and connect those to the corresponding pins on the Arduino. D4 goes to D4, D5 to D5, D6 to D6, and D7 to D7. Next, we'll hook up the backlight, the anode, to 5 volts using a 220 ohm resistor. Then hook the cathode directly to ground. And that completes the circuit. Let's go ahead and power this on and run our program and see what we have. All right, now that we have built our circuit and we've coded our program, let's go ahead and power this thing up and see if it works. Let's try it on hard. Well, thanks for watching my video. I hope you had as much enjoyment out of building this circuit and coding this program as much as I did. If you find value in these videos, please be sure to like and subscribe. And if you don't mind, down in the comments, let me know what type of projects you would like to see next. Until next time, please take care.